And we are ready to rumble. All right, so section 1.5, we're going to talk about linear inequalities in one variable. Now, before we start solving or do anything with the linear inequalities, the big thing, probably every time I teach this class, about half the students have not seen the notation. So if you've seen this notation, please just bear with me. But I don't assume everybody has, because it's not part of everybody's prior learning. Told you last time, as I prepare you for college algebra, one of the things I want to highlight is writing things properly. Math is a language. And so how do I communicate my answers to inequalities? When you take college algebra, this first page where we talk about what's called interval notation, you're going to use it every day in college algebra. I promise you. We're going to talk about things like domain and range, and when things are increasing and decreasing or something, and none of that might mean anything to you. Just trust me, you're going to use interval notation all the time. So here's what we're going to do. We're going to first take these intervals that we have, and we're going to do something that I assume you have seen before, which is graph them on a number line, so that we have a picture to see how to form and how to write intervals. So I'm going to do this first one. I don't think there's anything too stressful here, but remember, if you have a question, ask it. Sitting there confused doesn't do you any good. It doesn't do me any good. Okay, so ask whatever question. We got plenty of time today for any questions that you might encounter. So here we go. Looking at this, this says my x's are at the same time both bigger than -6 and less than or equal to 14. And I want to represent this as a picture. Where are these values? So first, what are my boundaries on this interval? Real obvious question, hopefully. What are the boundaries? Perfect. -6 down here and 14 here. So I'm just going to make a little mark. I don't do a whole bunch of marks just because I'm terrible at drawing, and I don't want to confuse anybody. Again, I'm tapping into some prior knowledge I'm hoping that you have. When you've graphed things like this before and you see something without an equals, that like a less than or a greater than, what do you put on the number line to represent that? An open circle, yes. What that open circle means, in case you're not familiar, is that's the end point, but that value doesn't count. Okay, everything as close to -6 as I can possibly get counts, but not -6. How about at the 14 end where I have an equal to? What am I going to put at that end? Fill it in, yes, because it means just the opposite. It means 14 is part of the interval, so we fill it in. And now when I go to shade on the number line, where am I going to shade to represent the values that are both bigger than -6 and less than or equal to 14? Am I going to shade on the left, in the middle, or on the right? In the middle. Yeah, the x's are right here in the middle. So I'm just going to do some shading here. There we go. That is the graph of that interval. Now, that's not interval notation. That's the graph, but sometimes pictures help us learn. So I just wanted to draw the pictures. So in the meantime, exercise 1 right next door. Go ahead. I'm going to give you 25 seconds. Graph that interval on the number line, please. I shaded in the middle because this says that x is greater than -6. So greater than -6 is everything to the right. But at the same time, it has to be less than or equal to 14. So that's what tells me to stop here at 14. So yes, that's why I shaded between the two. Yep, great observation. All right, what are your boundaries for exercise 1? Sure, 0 and 9. Great. This time, what am I going to put at both 0 and 9? You're going to use the same thing. Close circle. I'm going to close it off because both of those have an equal sign. So we'll do that. And then once again, the x's are bigger than 0 and at the same time less than 9. So that is this middle section right here. We doing okay? If you got a question, you need any clarity, please don't be shy with me. I love questions. It means you're learning. All right, example 2, my example. Again, I think you've done this, but I just want to be thorough here. So x is bigger than 2. This time I only have one boundary. What's the boundary number? 2. Yep, fairly obvious thing, but I want to ask the question anyway. And so now at 2, I'm going to fill in the circle because of that equals. Now this says all of my values, all of my x's are bigger than 2. So which way represents bigger on the number line? To the left or to the right? To the right, yes. So I'm going to go ahead and shade. We put an arrow on the end. The arrow indicates it keeps going in that direction forever. Okay, so don't just stop drawing your line. Make sure you put the arrow. That is good. So do exercise 2. I'll give you 15 seconds to sketch that out. So this time, my boundary is -6. And this on this particular example, there is no equals. So we use an open circle. We don't fill it in because -6 is not part of this set. And then again, it's a greater than, so I shade to the right. So use my arrow. One more example for each of us, and then we're going to talk about the new thing, which is called interval notation. So the last one, I've got x is less than -1. So my boundary, I think you would tell me, is -1. There it is. I'm going to do an open circle. And the only difference on this problem is which way represents less than, or the values being lower. Am I going to shade to the left, or am I going to shade to the right? Okay, we're going to go to the left this time. The number line is always the same. Okay, it's never going to be reversed. So always left means you're getting smaller. Okay, so do the same thing, exercise 3, please. So 10's my boundary. What am I going to do? Open circle or filled in circle this time? We're going to fill it in. Yep. Left or right shading? Okay, left. And to use your arrow. There you go. Okay. So hopefully, even if you don't have that prior knowledge, hopefully that's not anything too stressful. Just graphing. In fact, I don't care if we ever graph again. But I just wanted the pictures so we can talk about this thing called interval notation, which is today's learning. And so interval notation always has the following format. You're going to use 2 values. You're going to have a value that represents your lower limit on the left. Order is important in interval notation. Then you're going to use a comma. Then you're going to have a value that represents the upper limit. On each side of the interval, you're going to put one of 2 things. You're either going to put a bracket or a parenthesis. They each represent something different. A bracket, I'm going to use one of each. There's no rhyme or reason to what I'm doing here. A bracket you use when there's an equal. You would use it at the same point that you used a filled in circle. So if there is an equal, you use a bracket on that end of the interval. And if there's no equal, or you would use an open circle, you use a parenthesis when there's no equal. So that's going to be the more mathematical way to communicate to us what a number line would communicate, or what this statement written out with the x would communicate. We talked last time, we solve an equation, we write our answer as a set. Interval notation is the set. Okay, so we don't need to use squigglies or anything on these. So for instance, example 1, here we go. Example 1, I'm going to look at the picture. The picture's helping me learn and do this a little more quickly. What's my lower limit and upper limit of this one? Yep, -6 and 14. So I put a -6, I put a comma 14. Number order is important. You write interval notation in the same direction as the number line. What am I going to put at the -6 end of this interval? Why a parenthesis? Yeah, it's an open dot. There's no equality on that end. So I put a parenthesis right there. What am I going to put at the 14 end of this? A bracket. Why a bracket? There is an equal. You filled in the circle. Yep, they mean the same thing. So there is my interval that represents all the numbers from -6 to 14, including 14. Questions, comments, or concerns about that example? We'll try the next one. Exercise 1. Go for it, please. What are my limits on this problem? Perfect, 0 to 9. And this time I'm going to use the same thing on both sides. And that's what? Brackets, because there's equals. I'm just going to keep going. Remember, if you have a question, raise your hand. Don't be shy. There's no bad questions, I promise you, as we're going through. You're learning. All right, so here's the next one. What do I do now if I don't have both a lower and upper limit? So looking at this graph, the number 2. Is 2, according to the graph, the lowest value, meaning the lower limit, or is it the largest value, meaning the upper limit? It's the lowest, it's the lower. So we've got 2, comma. Now I have to express that there's no upper limit. And so in math, you might have seen this, we use what's called infinity, the infinity symbol. And the infinity symbol is like an 8 that's had too much beer on a Friday night. It's laying on its side now. Okay, so there it is. So that means it gets bigger and it never stops. Now on this one, what am I going to put at the 2 end of this? A bracket, because of the equals. Now what you put at the infinity side does not depend on the sign at all. You always put the same thing on the infinity side no matter what, because infinity is a direction, it's not a destination. You never get to infinity. So because of that, you will always and every time use a parenthesis on the infinity side. So the parenthesis, I'm going to write this down. You always use a parenthesis for infinity. That never changes. Does not matter what the inequality sign is. You always use a parenthesis. You tracking with me? We doing okay? Then please do exercise 2 right next door. So on exercise 2, the -6, is that a lower limit or the upper limit? Again, it's the lowest value. There's nothing to the left of -6, so that's as low as that gets. And then I'm going to put an infinity because there's no upper limit. There's no biggest value on this one. What am I going to put at the -6 side? Why am I putting a parenthesis on that side? Because there's an open circle. There's no equality. Great. That's the answer to that question. What am I going to put at the infinity side? Why do I put a parenthesis on that side? Because you always put it for infinity. Okay, so there you go. Parenthesis on both sides for that one. All right, one more example for each of us, and then that'll be interval notation, and we will keep practicing that today because this is how we will write our answers to the things we solve today. Okay, so this one right here, looking at this picture, this time the -1. Is the -1 the lower limit, meaning the lowest value, or is the -1 the upper limit, meaning the largest value? Okay, it's the upper, so comma, -1. This time, to represent that there's no lower limit, we use not just an infinity, but we use a negative infinity. Negative infinity means it's getting smaller. You would not put a negative infinity as the upper limit. Okay, so that these things are particular to writing our interval notation. The negative infinity functions just like the positive. You're going to put a parenthesis there because you're never going to get there. And on this particular one, since there's no equal sign on my inequality sign, I'm going to use a parenthesis at the -1 side. Exercise 3, please. All right, so again, 10 is my upper limit, so comma 10. The lower limit this time is what? Negative infinity. There is no lower limit. Perfect, well said, I appreciate your help. I put what at the negative infinity side of the interval? Parenthesis, because it's infinity, that's what you always put. And I'm going to put what at the 10 side of this one? A bracket, because of the equal sign. Great. Before I move on, any questions about interval notation so far? Yes.
So if the sign
Yeah, so that goes back to writing things properly. So the question, as I hear it, is if the signs were this way, well, that interval makes no sense. So you would never write it like that, because this is saying something that can't happen. It's saying x is less than 0, and at the same time it's bigger than 9. Do we know any numbers that are less than 0 and bigger than 9 at the same time? No. Less than 0 is negative numbers. Bigger than 9 is 10, 11, 12, 13. So this statement here makes no sense because it can't happen. So great question, because sometimes I see students do that. So you would do something completely different, and that's out of the scope of what we're talking about right now. Okay, great question. I do have one more thing to mention about interval notation. The last thing I said to you before you made the mad dash out of class last time is there's a mathematical way to write all real numbers. So all real numbers represents the whole number line, everything on the number line. So if you had to guess, if I want to represent the whole number line, what would you say the lower limit would be? Negative infinity. And then what would you say the upper limit would be? Positive infinity. Yes. So the whole number line, the way to write the whole number line in interval notation is negative infinity to positive infinity. And since they're both infinities, we will use parentheses. So if you remember on the sheet, you don't have to pull the sheet out, but here is the last problem we did last time from section 1.1. We did the identity, which was always true, and the answer to that was all real numbers. So now, instead of writing it like this, all real numbers, what you'll do, the more mathematical ways, you'll say, oh, okay, when all real numbers, the answer is negative infinity to positive infinity. And that is the way we write in interval notation the answer to that question. All right. Yeah.
Could you explain negative infinity? And when do we put negative infinity?
You're going to put negative infinity when your interval is getting smaller and smaller, when it's going left on the number line. Okay, so the negative means you're going left, and the infinity means there's no boundary here. It's just going to go forever. And just like positive infinity, the positive means you're going right, and then the infinity means it's never going to stop. Great question. See how easy it is? Yeah. So that means, so for instance, let me draw one. I'm going to flip my page over. Let's say we have this right here. We have x is greater than 1. Oops, you can't see it. You have x is greater than 1. Okay, so real quick on the number line, it looks like this. You've got 1, we've got an open circle, and then I'm going to shade this way. What I mean by that is this. 1 is not part of the set. So if I'm thinking of numbers that are represented here, like 1.1, that's bigger than 1, right? 1.01, that's bigger than 1. So every number, no matter how close to 1 you get, is part of that set, but 1 is not. 1 is just the anchor where we say it starts, but the value 1 would not be a number that I listed as part of this set. Sure. So now what we're going to do, where we're going to take this knowledge of interval notation and inequalities, is we are going to solve something related to what we did last time. We're going to solve linear inequalities in one variable. If you remember last time in section 1.1, we solved linear equations. And linear equations had an equal sign. That's how we knew they were an equation. How we know something's an inequality is it has one of these 4 symbols. It either has a less than symbol like this first one, a less than or equal to symbol like the second one, a greater than symbol like the third one, and last but not least, a greater than or equal to. That's what makes these an inequality. The steps for solving an inequality, thankfully, are almost no different than solving an equation. Okay, so that's the good news. So I'm going to flip the page. I'm going to do an insightful demonstration for you, and I've declared it insightful, to show and demonstrate for you what is the one thing you have to remember solving an inequality. You probably know this, you've probably seen it, but let's just live in the suspense. So here's what I'm going to do. -5 is less than 5. Is that a true statement or a false statement? Is -5 less than 5? Yes, that is true. Okay, great. So here's what I'm going to do the first time to this true statement. I'm going to add 4 to both sides. So we're going to add 4 to both sides of this true statement. And what I want to know is when I add 4 to both sides, do I still have a true statement? Okay, so let's see. What do you get when you add 4 to -5? -1, okay. What do you get when you add 4 to 5? 9. So when I put that less than sign in, do I still have a true statement? Yes, okay, it's still true. Great. So what I've just demonstrated to you, when we solve an inequality and we add something to both sides of the inequality, like we did for equations, or subtract, adding and subtracting are the same thing. If I add or subtract something to both sides, it doesn't change the truth value. There's nothing to worry about there. Okay, so we're going to be able to do that freely. So when we do example 1 in just a minute, and we add the same thing to both sides, we can know without a doubt that the same sign will go between the sides. Okay, well, here's what we're going to do next. The next one, I'm going to multiply both sides by 8. We're going to multiply both sides by 8 on the next one. Now remember, multiplying and dividing, same thing. So I'm multiplying by a +8. It could be dividing by a positive number. It doesn't matter. It's going to be the same conclusion. So when I multiply -5 by 8, what do I get? -40. When I multiply 5 by 8, what do I get? Okay, 40. If I put that less than sign in there, is it still a true statement? Yes. What, again, I've just demonstrated to you is multiplying or dividing by a positive doesn't change truth value. So here is what you've been waiting for. I know, I'm sorry to be so slow on the punchline. What we're going to do last is we're going to multiply both sides by, let's say, -8. Let's not be too clever. And we're going to see what happens. And then this is going to show us the one thing you have to be aware of solving an inequality. There's only one thing. What do I get when I multiply -5 by -8? +40. What do I get when I multiply 5 by -8? This time, if I put a less than, am I going to have a true statement? No. What do I have to do here to maintain a true statement? You got to flip the sign. Yes. So I've got to flip the sign. Now, if you are just hoping that I will summarize for you what you need to remember, congratulations, I'm just about to do that. So here is the summary of what you need to remember, the one thing you have to have awareness of when you're solving an inequality. Otherwise, it's the same process as an equation. And it is this: if you multiply, I'm going to write in parentheses, or divide, they're the same operation. If you multiply or divide by a negative, I'm going to underline negative. That's the most important word in this sentence. If you multiply or divide by a negative, you must flip the inequality sign. That's how you keep the statement true. So just to review before we get going, if I add or subtract, do I have to flip the sign? No. If I multiply or divide by a positive, do I have to flip the sign? If I multiply or divide by a negative, do I have to flip the sign? Yes, that's the only time. Okay, great. We're ready. So let's do example 1. I'm going to work these examples sort of quick because most of the steps are the same. If you miss something, don't be shy, okay? I'm not here for me, I'm here for you, okay? So just let me know. So example 1, x minus 7 is less than -12. What am I going to do to both sides of this to solve it? Add 7. The opposite of subtracting 7 is adding 7. That's what we said last time. That still applies right here. So on the left side of this, the 7s cancel, and I have x. On the right side of this, -12 plus 7 is -5. What sign do I put between those? It stays less than. Fantastic. Now, at this point, if you need, in order to write something in interval notation, if you need to draw a picture at first as you're learning this, great, do it. Don't be shy. I'm just going to think it through. If all of my values are less than -5, if everything else is less, is -5 the lower limit or the upper limit? Upper. If everything else is less, -5 is the upper limit. And that means negative infinity means less. Everything is less than that. Parentheses at the infinity Because there's no equals, parentheses at the -5. And there's my answer to the problem. All the values from -5 down are solutions to this inequality. All right, exercise 1. I'm going to give you about 30 seconds to do that problem, please. There's one step to solve this problem. What is that one step? Add 10. The opposite of subtracting 10 is to add 10. Great job, everybody. So that means on the left, when I do those reverse processes, those cancel, and I have x. -7 plus 10 is 3. What sign goes between those? Greater than. You do not change the sign. Adding does not change the sign. Everybody with me? Tracking with me? Okay, so now all my values are bigger than 3. If all of my values are bigger than 3, is 3 the lower limit or the upper limit? It's the lower limit. That means infinity is the upper limit. I'm going to put a parenthesis at 3 because there's no equality. I'm going to put a parenthesis at infinity because it's infinity. If I need to add clarity to anything, please stop me. Let me know. I'm just going to keep going though, because I don't want to bore you. So I got a fine line I'm walking here. Example 2. Example 2 says -4x is greater than or equal to 20. So what's the reverse of multiplying by -4? Dividing by? Yes, that keyword, negative. There's the one thing you have to notice. I'm dividing by a -4. So on the left, a negative divided by a negative is a positive 1x. On the right, 20 divided by -4 is -5. This time, what sign goes between the sides? Why did you flip it? Because you divided by a -4. Yes, so it becomes less than or equal to. Beautiful, well said. Everybody tracking on why we flipped that sign? You noticing? All right, and so now I write that. We already did a less than. If my values are less than or equal to -5, that means -5 is the upper limit. Means everything else is less, so negative infinity. Parenthesis at the negative infinity, and a bracket this time at the -5 because of the equality. Do the problem right next door, exercise 2. So what did you do to both sides of this? Divide by 5. Did I divide by a -5? No. The reason I gave this problem is I just want to make sure we're clear. I understand that there's a -30 on the right. It doesn't matter what sign that number is. It only matters the sign of what you're dividing by. Okay, so we're dividing by a +5, so that leaves an x on the left, a -6 on the right. And since I divided by a +5, we leave it less than or equal to. So if you flip that sign, you're not supposed to on this one. It's a less than problem. That means -6 is the upper bound, negative infinity is the lower bound, and a parenthesis here, bracket here. Anything confounding you? Because now the rest of the problems today, okay, we're just practicing. I want you to get nice and good at this because, again, solving, when you take college algebra, you're going to solve so many inequalities of different types of problems in that class, and I want you to be good at it. Okay, so we're just going to go back through the same things we did last time. All these problems should look really similar. So example 3. This is going to be my last one that I do with you. All the rest you're going to do, and then we'll check it together. So example 3. What did we say last time is the first thing that should attract my attention on this problem? Yeah, the parentheses. Let's distribute. So -3 times x is -3x. -3 times 4 is -12 plus 2. Distributing does not count. We have not done anything to both sides, so leave that a greater than or equal to. And then 7 minus x. The next thing we do on these problems, we determined last time is what? To make this look prettier. Combine our like terms. Yes, thank you so much. Excellent. So negative 12 plus 2 is negative 10. And now we're ready to solve. And almost all the time, I put X's on the left, numbers on the right. You're welcome to do different if you want. So I'm going to put all my X's on the left. So to do that, this negative X, I've got to add. I'm doing the opposite. This negative 10, I've got to add. I'm doing the opposite. Have I lost anybody? Negative 3x plus 1x is negative 2x. The 10s cancel because I put the numbers on the right. All I've done is added things. Adding does not change my sign, so greater than or equal to. 7 plus 10 is 17. And the x's cancel because I put the x's all on the left. Last but not least, one final step. This is always the last step. I'm going to divide. And what's significant this time about what I'm dividing by? It's a negative, yes. So that means instead of a greater than, I'm going to make that a less than or equal to. A positive 17 divided by a negative 2 is a negative 17 over 2. I don't mind if you write negative 8.5. My math lab might be contentious with you on some problems. I don't know. That's the one problem with having your homework online is it sometimes has limitations. So I apologize for that. And so then since this is a less than, that means negative 17 over 2 is the upper limit. Negative infinity is the lower limit. And I put a bracket at the negative 17 over 2. If you have a question, ask your question. If not, exercise 3 is right next door. Yes, what's up? Hang on, if I'm multiplying what? Sure. No, I flip it if I multiply by what? A negative. If you multiply by a positive, you don't flip it. Okay, so if you multiply or divide by a negative, that is the only time you flip the sign. If you multiply or divide by a positive, you don't. Just like exercise 3 right here. We divided both sides by a positive, which is the same thing as multiplying by a 1/5. Okay, I didn't flip the sign because it was positive. Okay, great question. I'm glad you're getting clarity. That means you're learning and I love it. All right, go ahead and try exercise 3. All right, remember I'm cutting the difference here. I know some of you are done. That's great. Some of you are not done. That's great. We all work at different paces. I understand that. When I make the test, I make it so that if you work a little slower, you'll be just fine. So if you're still working, keep working. I'm going to get started. I'm going to distribute first. So I have 6x minus 6. That's my first set of parentheses that I get rid of, plus the 3x. Greater than or equal to, I leave the sign alone. Then I have negative x and then negative 3x minus 6. I'm going to collect like terms next if they occur. And on the left, I have 6x and 3x. That's 9x minus 6. greater than or equal to. I've not done anything to both sides yet, so there's no need to worry about the sign. And on the right, a -1 and a -3 is -4x minus 6. We doing okay? I know that's busy work and it's not always fun. Just make sure you pay attention to the details. Use your calculator if you need to. Now I'm going to put the x's on the left, numbers on the right. So to put my x's on the left, I'm going to add the 4x. To put my numbers on the right, I'm going to add this 6 right here. We encountered this situation in the first section. I just wanted to reiterate it so that we know we're comfortable with it. 9x and 4x, that's 13x. The 6's cancel because I put all my numbers on the right. I've only done addition, so my sign does not change. The 4x's cancel because I put all my x's on the left. What happens to the 6's on the right side, though? So what value do I use here? Yeah, 0. Don't be scared of 0. It's a number. There we go. And then I divide both sides by 13. That's a positive 13. So do I flip the sign? Nope. You leave the sign as it is. So greater than or equal to. If you have 0 of something and you divide it into parts, each part is 0. So my values are bigger than 0. So that means 0 is the which limit? Lower. Great job. Sounds like you're doing excellent. So I hope that's true. I appreciate your participation. That helps me know. I'm going to flip the page. See, we just got some more practice problems. There's a few here that we're going to get to that involve fractions, so we can practice that again. So we're going to start with exercise 4. We're going to work down the left column. I'm going to give you about 2 minutes. Exercise 4. Make as much progress as you can on exercise 4 in 2 minutes, please. All right, so let's see how you did. Remember, any questions you have are good questions, so please ask them. You've been doing good today with that, so hopefully you're getting some comfort. So I picked this problem again, kind of the similar situation when we solved equations. I've got to distribute, but you do not do, if you did the 5 minus 2 and got 3 and distributed that, that's not right. You subtracted before multiplying, and that's not the order of operations. It's a common mistake. That's why I keep bringing it up, because I want you to remember. So what I have to distribute is the -2. So I have -2x. -2 times -4 is +8. My like terms, 5 plus 8 is 13 minus 2x, or -2x plus 13. The order is unimportant. I'm going to put all my x's on the left, numbers on the right. So here we go. X's on the left means I'm going to add this 4x to get all the x's on the left. Numbers on the right means I'm going to subtract this 13 to get the numbers on the right. Is anything confounding anybody? You doing okay? Okay, Negative 2x plus 4x is 2x. I've only added and subtracted. Adding and subtracting does not affect my inequality sign, so less than. And then 11 minus 13 is negative 2. I'm going to divide by 2. That is a positive 2, so it's x is less than negative 1. I don't change the sign. X being less than 1, or excuse me, x being less than negative 1 means negative 1 is the upper boundary, negative infinity is the lower, and a parenthesis on both sides. There we go. If you have a question, comment, or concern, please ask. In the meantime, go down to exercise 5. The reason I've got exercise 5 here is this is the one situation where I would put x's on the right because there's no number on the right that needs to be moved. So just to save myself steps, I'm going to put all the x's on the right on this one. If you don't want to do that, you can flip-flop a bunch of things and do x's on the left. That's fine, but I'm preparing you. So do exercise 5, please. So the question is, why would I put them on the right? See, in the previous problem, I have a number over here on the right. So I could put I have all my numbers over here on the right. So I put the x's on the left. Here, there's no number here. So it would just be an extra step to bring my numbers over here onto the right and then x's on the left, which is a perfectly fine thing to do if you want to do it. I'm just lazy. So I'm going to do the minimum number of steps that I have to do. Okay. All right, so let's see how you did. Give me any feedback you need to. So I have x, then negative 2 times x is negative 2x. Negative 2 times negative 4 is plus 8 is less than or equal to 3x. I'm going to combine my like terms. So x minus 2x is negative 1x or just negative x. And then this is the situation I was talking about. If you want to put x's on the left and numbers on the right, that's fine. What you will do is you'll bring the 3x, you'll subtract 3x from both sides, and then you'll subtract 8. And that's a perfectly wonderful thing to do. But again, mathematically, I'm lazy. So since I see that I have no numbers to move around, I'm just going to take the negative x and add it. And just put all of my x's over here on the right side. That way I'm just doing one step instead of two. So now I have 8. I don't flip the sign. 3x plus x is 4x. And when I divide, I have this x. Now, at this point, I have a suggestion before we write interval notation. If you are fully competent and you are comfortable with this, I am not always comfortable, to be honest with you. I'm scatterbrained. But if you're comfortable reading from the perspective of the x, then you see that this is x is greater than or equal to 2. But I know we're used to reading left to right. That's not necessarily an intuitive thing. So here's my recommendation. When you have to write your interval notation and you've got your x over here on the right, what I would recommend doing is flipping that whole statement around. And what I mean by that is I'm going to take the x, I'm going to put it over here where I'm used to reading it on the left. I'm going to put the 2 over on the right. And then I notice the pointy part here is pointing at the 2. So the pointy part is going to stay pointing at the 2. And there's my statement in a way that I'm more used to reading it from left to right. And now I see that my x's are bigger than or equal to 2. So that means 2 is the lower limit. Infinity is the upper limit. Bracket, parenthesis should be what we have. Before we move on to the remaining problems, just to review fractions and make sure we're getting a little more comfortable. I know we're never fully comfortable with them. Is there a question about anything we've done so far? All right, so exercise 6. This is the simplest. Remember, simple isn't easy. Simple just means fewest steps. This is the simplest fraction problem. There's only one fraction. There's one term on each side. So remind me, what am I going to multiply both sides of this by? 4. Go for it. Multiply both sides of this by 4, and then come up with your solution, please. All right, let's see how you did on this. You told me the common denominator here is 4, so let's multiply both sides of this by 4. So I'm going to multiply here 4 over 1. Even though the right side is not a fraction, you still have to multiply by 4. Is this a positive 4 or a negative 4? Am I going to change the sign? No. Okay, leave the sign alone because you've multiplied by a positive 4. So 3x minus 1 is greater than 20. Add 1. This is not the most complicated of the problems we've done. Then I'm going to divide by 3. And we get 21 divided by 3 is 7. I didn't have to change the sign at all on that one because I never multiplied or divided by a negative. And so since my x's are bigger than 7, that means 7 is the lower bound, infinity is the upper, and parentheses. Questions about that fraction problem before we do the next fraction problem? Okay. Exercise 7. Here's what I would like you to do. I'm going to give you 15 seconds. I want you to write down somewhere. Don't shout it out. Write down somewhere what the common denominator is that you're going to multiply on both sides of this. What's the common denominator? 6. The lowest common denominator is 6. So that's what I want you to multiply on both sides of this and solve this problem, please. Common denominator 6. There's only 2 terms. One term on the left, one term on the right. All right, so make sure you keep up with me. Let me know if you don't see where a number is coming from. On the left side, how many times does this 3 go into the 6? 2 times. So what is the new number in front of the parentheses going to be? Yeah, 2 times 2 is 4. Yep. Did I multiply by a negative? Nope. So I keep the sign greater than or equal to. And then on the other side, 2 goes into 6 how many times? 3 times. So what's the number in front of the parentheses here? There's the 3 from the fraction times the 3 that's left over. That is going to be 9. Even if you made a mistake, mistakes are okay. Remember, don't beat yourself up. It means you're going to learn. Does anyone not see where that 4 and that 9 came from? If you got that, then fraction should not cause you much problems. The rest of this problem is just like all the others. So 4 times 3 is 12x. 4 times negative 1 is negative 4. 9 times 2x is 18x. 9 times negative 3 is negative 27. I'm going to put the x's on the left and the numbers on the right. So x's on the left means I'm going to subtract this 18x to get all of my x's on the left. Numbers on the right means I'm going to add 4 to get all of my numbers on the right. $12x minus 18x is negative 6x. I have only added and subtracted. Adding and subtracting does not affect my sign in any way, so it stays greater than or equal to. Negative 27 plus 4 is negative 23. Now I divide by -6. A -6 divided by -6 is a positive x. -23 divided by -6, a negative divided by negative is a positive 23/6. Since I divided by a negative, the sign instead of greater than becomes less than or equal to. Little word of advice, don't pre-turn the sign. Sometimes I find that students, like when you're done adding here, you'll see ahead of time that there's a -6 and you'll flip the sign at that point. Don't flip the sign until you do the division. What ends up happening is a lot of students will then flip it a second time and you end up getting the wrong answer. Okay, so only flip when you do the division. This is my values are less than 23/6. So 23/6 is the upper bound, -infinity, and there we go. There's my interval answer. If you got a question, if something is not clear, please ask it. In the meantime, exercise 8 up at the top. I would like you to please take 10 seconds and write down what you think the common denominator is that you're going to multiply all the terms by. What's the common denominator, do you think? 20. Yep, you got a 5 in one denominator, a 4 in the other. You could do the listing method like I showed you last time, or in this case, 5 times 4 is just 20. So the common denominator is 20 that we're multiplying by. So go for it. I'll give you a couple minutes to make as much progress as you possibly can on that. All right, I'm going to get started. Keep working if you're working. Don't let me distract you. So in the first fraction, 5 goes into 24 times. So what's the number in front of the parentheses going to be there? Yep, the 4 that's left over times the 3 is 12 times t minus 2 minus 4 goes into 25 times. And since there's a 1 in the numerator of that, 5 times 1 is 5 times 2t minus 7. Less than or equal to. And then don't forget, I know that there's no fraction over here, but you can't change the problem by not multiplying. So you have to multiply by 20 on both sides. So that makes 60 over there. At this point, the rest of this is what we've done like 1,000 times already. So I'm hoping once the fractions are gone, that's the hard part to these problems. I get it. And once you're done with that, I hope the rest of this goes a little more smooth. So we've got 12t minus 24. And then minus 10t plus 35 is less than or equal to 60. Like terms, 12t minus 10t is 2t. Negative 24 plus 35 is plus 11. All of my variables already are on the left, so I've just got to move that 11 to the right. And I have 2t is less than or equal to 49. And last but not least, we're very used to this being our last step. I divide both sides by 2, and I get t is less than or equal to 49 over 2, or 24.5, whatever makes you happy there. Since my values are less than that, that means 49 over 2 is the upper boundary. The negative infinity is the lower boundary. And there's my interval. All right, we've only got 2 more problems, so your chances to ask questions are diminishing. Please make sure that you leave here feeling confident, so that you're before I see you in the next 5 days, you're looking forward to coming back to class on Monday. Exercise 9, 10 seconds. Write down what you think the common denominator is for those 3 terms. All right, what's the common denominator among 4, 2, and 5? You wrote down what? 20. Yep. Listing method would work. If you multiplied them all out and said 40, 40 will work. You'll just have bigger numbers than me. Okay, but go with it. Right, so in the first fraction, 4 goes into 25 times. So 5 times the 3 that was already outside the parentheses, 5 times 3 is 15 times x minus 2. Then we've got plus, and then 2 goes into 20 10 times. 10 times 1 is 10, greater than. And then 5 goes into 24 times. 4 times the 1 that's already outside is just 4. X minus 8. Again, that's probably the hardest step to the problem. Anybody not sure of where those numbers came from before I pick up the pace and finish this one up? All right, we're gonna distribute, collect like terms, x's on the left, numbers on the right. Same thing every time. So hopefully you've done enough of these that it's second nature. You're doing these in your sleep now. So we've got 15x minus 30 plus 10 is greater than 4x minus 32. 15x, and then negative 30 plus 10 is negative 20. X is on the left, numbers on the right. So I'm subtracting 4x to get the x's on the left. I'm adding 20 to get numbers on the right. 15 minus 4 is 11x. Negative 32 plus 20 is negative 12. And last but not least, one more step, divide by 11, and I get x is greater than negative 12 over 11. Since all of my values are bigger than that, that means negative 12 over 11 is the lower limit, infinity is the upper, and we've got parentheses. One final problem for the day and for the week. Exercise 10. So again, 10 seconds, write down what you think the common denominator is for all of those terms. What is the common denominator you're using? 6. You can use 12 if you just multiplied all three numbers together, that's fine, but 6 is the lowest common denominator. That's what I will be using. All right, let's finish up the busy work. And then if you got any questions for me, I'll be here as you leave class. You can ask whatever you want. So 3 goes into 6 and leaves 2. 2 times the negative 2 is negative 4 times x minus 3. Less than 2 goes into 6 3 times. So I got 3 times 5 minus x. And then plus 2 goes into 6 3 times. And so I'm left with plus 3. Again, that's probably the hardest part to the problem, is getting rid of those fractions. Hopefully the rest of this is a relief. I have negative 4x plus 12 when I distribute, less than 15 minus 3x when I distribute, plus 3. I do have a pair of like terms. 15 plus 3 is 18 minus 3x, or negative 3x plus 18. The order of those two terms does not matter at all. I'm going to add the 3x. I'm going to get all of my x's on the left. I'm going to subtract 12 so I can get all of my numbers on the right. Negative 4x plus 3x is negative 1x, or just negative x. All I've done is added and subtracted, so I do not have to flip the sign. 18 minus 12 is 6. Very last thing, final step, I'm going to divide by negative 1. And since I divided by a negative, I now do have to flip the sign to greater than. And since all of my values are greater than negative 6, that means negative 6 is the lower limit, infinity is the upper, and I use parentheses on both sides. And that is that.